In this video, we introduce the Saliency Prediction method with the incorporation of external knowledge. This work is presented by Yifeng Zhang, Ming Jiang, and Qi Zhao from the University of Minnesota. Saliency prediction models simulate human attention by predicting where they look. They can be applied in many computer vision systems to quickly localize important visual features and improve their performance. Eye tracking studies suggest that saliency is dependent on not only the current visual input, but also people's prior knowledge. For example, different objects can be seen in the same environment, and people tend to look at semantically relevant ones. When we see a man standing in the kitchen holding a bottle, the strong semantic relationship between the man and the bottle directly attracts attention. Therefore, knowledge about such relationships can play an important role in saliency prediction. Existing saliency models focus on learning the attention patterns from human eye tracking data. Without considering semantic relationships, most of them cannot correctly prioritize multiple objects, especially in a complex scene. In this work, we explicitly incorporate externally modeled semantic relationships into a saliency prediction network to improve its performance and generalizability. We develop a saliency prediction network that explicitly detects objects in the input image and computes the saliency map with their semantic relationships taken into account. Specifically, given the visual features of the detected objects, we compute their pairwise relevance to construct a semantic proximity graph. The connectivity between each pair of objects suggests that they are closely related. The prediction of this graph is supervised with ground truth graphs obtained from external databases. For example, they can be built with image captioning data on Microsoft Cocoa dataset, or the semantic relationships from the WordNet. Nodes in the graphs represent object categories, and the edges represent semantic proximity between different objects. Based on the semantic proximity graph, we propagate object features using a spatial graph attention network. So the saliency of an object is not decided based on the features of itself, but with its related objects taken into account. These object features are concatenated with the spatial feature maps of a baseline model to compute the output saliency map. We conduct experiments on 4 publicly available datasets with 6 saliency evaluation metrics. Our models outperform the state-of-the-art saliency prediction methods on most of the metrics. In particular, on 2 evaluation metrics, linear correlation coefficient and normalized scan path saliency, our method shows significant performance improvements over the baseline, suggesting the effectiveness of explicit knowledge incorporation. Our method performs the best for complex scenes with many objects in the foreground and background. These examples show that explicitly incorporating semantic relationships can help saliency models to correctly predict the relative saliency among different salient regions. Please refer to our paper for more details. Our data and code are available online.